This is an introduction to SNIPeR, the sewer network information performance and reporting system used at Northumbrian Water. The system has been in place since 2016, but here are some reminders as to why the system was required in the first place. Sewer flooding is regarded as a significant operational problem faced by the company. Pollution is also an important indicator of sewer network performance. The problem is we don't know where it's going to happen. We can't predict it. 70% of flooding events happen in places we've never had flooding before. Most of our sewer network is a combined system, which means it carries foul sewage from homes and businesses, but it also carries surface water runoff from properties, pavements and roads when it rains. Most of it flows through the pipe networks to our treatment works, but sometimes it can escape from the network. The total length of the network is 3,000 kilometres, 20,000 miles. There are a number of different factors which can cause sewage to escape from the network. If the sewers aren't big enough to cope with rainfall, this is termed as hydraulic overload. Blockages can also be caused due to silt building up and other solids in the sewers. Blockages can be caused by people flushing things down the toilet that they shouldn't, such as nappies and baby wipes. Blockages can be caused by accumulation of fats, oils and grease. They can be caused by tree roots intruding into the sewer, usually through joints. There can also be equipment failures, for example pump failures. Sewage can escape from the network in three different types of locations. The first two are in controlled ways. That is combined sewer overflows, of which we have 1,300, emergency overflows where we have approximately 1,500, and uncontrolled escapes with manholes, approximately 300,000. This results in many alarms that can be presented. A SCADA screen is shown here, where there are a number of alarms shown, but not all can be reacted to. So some intelligence is required to prioritize where a crew can be sent. This is mainly to distinguish between blockages and rainfall. This slide shows an overview of the SNIPeR system, showing at the top the information that's presented to the user, which can be done in many ways, for pie charts, time series graph, spatial, text message or email. Then there's the analytics layer, which absorbs information from 4 different sources. Firstly, Met Office rainfall, actual rainfall, then SCADA data itself, GIS information, and also forecast information, the next 6 hours of rainfall from the Met Office. In terms of the data journey, looking at the collection from a data logger, that will be captured into the SCADA system. Then that hops into the MIP system, and there's about a 5-minute interval for doing that. At this stage, these are the data sets that will be pushed through to SNIPeR. So we've got MIPS information, which can be 2 or 15-minute intervals, rain radar, which is 5-minute interval data, and then nowcast, which is a 6-hourly forecast of rainfall, which is the 15-minute intervals. They are then pushed into SNIPeR for analysis and then presentation. For an alarm to be processed within SNIPeR, the time from the data logger to the alarm dashboard is approximately 30 minutes window. Within SNIPeR, there are 2 areas of functionality: sewer levels and sewage pumping stations. Within sewer levels, there are dashboards for dry weather alarms and their history, spatial alarm representation, which is the area situation dashboard. Also, it presents CSO and manhole attributes. For sewage pumping stations, a daily performance indicator email is sent out every morning. It also includes pump cycle performance indicator information, wet well overflow alarms, under over activity, abnormal dry weather trends, and pumps out of service.